Right then, question 3. We're looking at a sector. Okay, we're looking at a sector, and you need to know these formulas really for a sector. The area of a sector when you're in radians, and the question does state that we are working in radians to start with. So if we have a look at this, the information, it says theta is in radians. We've got the sector AOB. Centre is at 0, and the angle is just theta. Okay, so the area of the sector is 11 centimeters squared. So we're given the actual area. The formula for the area, which you should know, in radians is a half r squared theta. That should be in your mind ready to go. It also talks about, given that the perimeter of the sector is 4 times the length of the arc. So there's an equation there that we can set up. Arc length in radians is just r theta. The perimeter is obviously all 3 edges, if you like, all 3 sides of this sector added together. So we've got a few equations that we can set up. So let me grab the pen. Let's start getting our teeth into this a little bit. I'm still on highlighter there, aren't I? Sorry about this, I'm getting old. Here we go. So the first thing I'll do, okay, we can start with this first bit of information about the area. And I'm just going to see this pen is slightly pushing out of me here. So the area, 11 centimeters, is equal to the area, which is a half r squared theta. That's one part of our formula. We can use this in the question. The second part says the perimeter of the sector is 4 times the length of the arc. So 4 of these is equal to 1 perimeter. Alright, so 4 lots of r theta, that's the arc, is equal to the perimeter, which is, the perimeter is all the way around, isn't it? All the way around the shape. So there, and back there, that's the perimeter. So the perimeter is made up of 2 radiuses plus the arc, which is just r theta. From our formula, the arc length, the arc is r theta. So r theta. Okay, those are the 2 things that we're going to use to try and work out the value of r. Now I've got 2 formulas. They've both got r in, they've both got theta in. So I kind of want to eliminate one of the variables, and as I'm finding the value of r, I'm going to use one of my equations to get rid of theta in the second one. So I'm going to take the first one and try and get this in, make theta the subject of the equation. I want theta equals something. So let's times both of these sides by 2. 22 is equal to r squared theta, times in by 2 gets rid of that half. And then rearrange, so we've got 22 over r squared. That is equal to theta. Alright, so here we go. We have our substitution for theta in terms of r. So we can pop that into this equation over here. So let's do that. We've got 2r plus r times theta, which we've just said is 22 over r squared, which equals 4 times r times theta, which is 22 over r squared. Okay? Simplifying this now, we need to work out let's simplify these fractions first. So we're going to get 2r plus r times, well, r over r squared. That's going to cancel out one of the r's there. So, and cancel this one out. So we're just going to end up with 22 over r is equal to, well, 4 times 22 is 88. And an r over an r squared is just going to leave you with an r on the bottom. So we end up with this, okay? And obviously, it's up to you what you want to do at this point. I would just times everything by r by the looks of it to get rid of those fractions. So 2r squared, this term is not over r, so we're going to get an r squared, plus 22 equals 88. Minus 22 from both sides. 2r squared equals 66. Divide by 2. R squared is 33. And then square root. So r is going to be equal to plus or minus root 33. And you may be aware that we cannot have a negative length. So we only really want the positive version for our answer, which is root 33. Okay, hope that's been helpful.